the center. Interesting one over here, there's this coil, this garland around that column there, and if you, mathematically, we would nowadays describe that as a helix. It's a spiral that's been wrapped around it's a spiral that's been wrapped around a pole. And if you're a good artist, if you want to faithfully reproduce what you see here, well, how do you draw that? How are you going to draw the helix? So there are a couple more examples of some basic shapes that we have to focus on. This is something called a bishop's crosier, and these are from the Metropolitan Museum of Art. Again, straight lines and circles, very easy to draw, but the other objects in daily life, there's a variety of shapes that we need to be able to construct. And again, if you want to take Dürer's viewpoint, well, anybody could just do a freehand drawing of what a crosier looks like, but if you want to draw these properly, there should be some sort of quantifiable description of how you should draw these things. And so Dürer talks about, so let's talk about some of Dürer's curves. If you look at most histories of mathematics, a lot of time will be spent on Dürer's curves, and I'll talk about a few of them. One of the important ones that Dürer goes into some detail on is a spiral, and just as a quick overview of the construction. So here we're going to create something that's going to be a spiral. Well, how can we do that using the tools that we have? Again, it's easy to draw circles, it's easy to draw straight lines, so can we use those together to draw a spiral? And so Dürer describes the following construction. What we're going to do is we're going to take a straight line, we're going to divide it into fourths, and then we're going to bisect one of those fourths, and this point F here in the center is going to be the center of our spiral. Now, Dürer's construction actually begins from the outside. So we'll draw a semicircle with the AB as the diameter. We'll draw another semicircle with BC as the diameter, and we'll keep drawing these semicircles where our diameters keep dropping. And Dürer and what we obtain is a spiral that has been created purely using the arcs of circles. Now, one point that's worth noting here is Archimedes had described what a spiral looked like, had described a very specific type of spiral. This is a very non-Archimedean spiral. It's actually, if you were to superimpose a graph of this on an Archimedean spiral, this is actually a very bad match to what Archimedes would consider to be a spiral. So in this particular case, if Dürer is really trying to describe a mathematical spiral, he's not doing a particularly good job. On the other hand, in some other cases, he does some very interesting things. For example, going back to that helix, from architectural plans, apparently, Dürer adopts this following idea. If I want to view what an object looks like, what I can do is I can draw the ground plan of the object, and then essentially draw a projection of what the vertical dimension of that object would look like. And so Dürer's description of a spiral, well, we'll begin by drawing a circle. We'll divide it into a number of pieces. And what we're going to do is we're going to take each piece, and that is going to be the location. We're going to raise that up a certain amount. And then the second arc over, we're going to raise that up twice as much, and so on. We're going to build up the horizontal layers of the spiral by taking the ground plan and then projecting it vertically. And Dürer carries this one step further, which is now one of the classic curves from Greek geometry. Some of the classic curves from Greek geometry include the conic sections, and we all know how they describe. You take a cone, you slice it with a plane that meets certain criteria, and the question is, well, how do you translate that intersection of the cutting plane with the cone into an actual curve? And Dürer's description is, Dürer gives a very nice description of how you would do something like this. So we'll start off with the cone. There's our cutting plane, and we're going to do two projections. The first projection is going to be from this vertical position of the cone to this, which you can view as your ground plan.
There is a laser pointer. If you want, it's sort of the odd button out, sort of centered.
There we go. Okay, excellent. Okay, so what we're going to do is we're going to slice the cone this way, and we're essentially going to take a look at the ground plan, which is going to look something like that. And it's the important thing here to note is that these horizontal lines here give us the radius of a circle down here that this particular bit of the cutting plane is going to go through. So if so what we can think about is the following. If I were to actually take this part of the cone off and look straight down from here, this is what we'd see. And note that we'll still see a circle because we haven't yet adjusted ourselves to the proper plane. But then Dürer identifies that the next step is these lengths here, these vertical lengths there, can then be translated back into the horizontal lengths up here. So we're going to take our cone, we'll slice it, we now have our ground plan, and then these lengths here give us the horizontal chords up there, and we can use that to draw our ellipse. And Dürer does the same thing for the hyperbola and also for the parabola. What's interesting about this, I think, or one of the things I think is very interesting